Hello students, today I will explain an important concept that is called law of conservation of momentum. Law of conservation of momentum. What this law states means, if external force acting on a system, is zero, then the total momentum of a system is conserved. This is the statement of this law of conservation of momentum. System, how can we consider a system? For example, a passengers inside the bus including a driver, so 40 passengers plus one driver, we can consider that is one system. And 4 persons on a boat, that boat and 4 persons, we can consider that is our system. Like that we can able to consider a system. That means if the bus is moving with some velocity, means if I ask what is the velocities of individual person, means definitely we will say the same velocity as what the bus is moving. If bus is moving with 50 km per hour, each and every person also observes is moving with 50 km per hour. Then such a type of system we can consider. So in that system, if net external force is zero, okay, on a system net external force is zero, then what happens? The total momentum of a system remains constant, or the total momentum of the system remains same. That is, and also remember the internal forces doesn't change the total, it will not affect the total momentum of a system. So what is this external force and internal force means? For example, last class also I explained a free body diagram. Okay, in this 2 blocks, you know that this is block 1 and this is block 2. Now you are applying some force, isn't it? Then I can able to consider block 2 separately, and I can able to consider block 1 separately. Block 2 as separate system, block 1 as separate system. Then if I see the forces acting on block 2 and block 1, on block 2 F force is acting in this direction, and block 1 applying normal force, right? That normal force is acting in this direction. Similarly on block 1, the normal force is acting in this, on block 1 the normal force is acting in this direction, right? So separately I have considered body 2 is one system and body 1 is one system. Then these are these forces become external forces acting on a body. So if I choose this 2 body as a system, then block 1 and block 2 F force is acting, then this is only the external force acting on the system. Now no need to represent normal forces. Why? Because if I consider these 2 as a system, these normal forces becomes an internal forces. Okay, I hope you understood the difference between the normal internal force and external forces. That is depends upon how we are considering a system. And remember, the internal force doesn't create any motion. That means if a person standing inside a bus and pushing the bus will not move. Why? Because in that time the force is considered as internal force. The same person come outside and if you push the bus, Suppose if you apply a large force, then there is a possible of the bus can move. If the person inside the bus and pushing the bus means definitely the bus will not move. Why? Because that force is an internal force. And in this law of conservation of momentum, what I said, net external force is 0. We can consider the total momentum of a system is constant or remains conserved. For understanding this one, let us consider this is a mass m1, this is a body of mass m1. This is moving with speed u1, and another body of mass m2, and moving with speed u2, and in the straight line, in the straight direction, right? Then these two bodies is our system, not an individual body. These two bodies is our system. It is having some mass and moving with some velocity, it is having some momentum. Here also it is having some momentum. Then let us say this body is moving with more speed. Then what happens? Definitely after some time this body will collide this second body. That diagram I will write. Okay, the first body, that mass m1 will collide the second body, that mass is m2. In this time the momentum will exchange. That means the m1 mass will apply force on m2. In this direction I can represent force on 2 by 1, F21. And in the similar way m2 also will apply force on m1 newtons. Third law, okay, m2 body also will apply force on m1. That force is force on 1 by 2, F1, 2. Both are acting in opposite direction. Both forces are equal in magnitude, opposite in direction, and this when the body will collide this body, no, in that time interval is delta t. Okay, body is moving in this direction means another body, this is m1 mass, this is m2 mass, will collide, and this body also starts moving continuously means during collision how much time it takes? A very small interval, delta t time it will takes. Then this is the condition before collision, and this is the condition during collision. And next, after collision, what happens? They may stick together, or they may like this also. Every possibilities are there. This is m1 mass and this is m2 mass. Okay, this m2 mass will move with the different speed as it is moving earlier. It is earlier moving u2, no, its final speed becomes v2. It is moving with u1, right? Finally it will move with v1 speed. This is what I can write after collision. So see here, how can we able to say the total momentum is conserved? Means suppose it is moving with 10 meter per second. Its mass is, let us say, 2 kg. Okay, 10 into 2, that is 20 kg meter per second, or 20 units momentum, let us say. Its momentum is 20 units. Suppose it is moving with 20 here, it is moving with 5 meter per second. And its mass is, let us take 1 kg. So altogether its momentum become 5 units. Here 20 units, 5 units. The sum of the momentum before collision is 25 units, right? So this body collides the second body. During collision what happens? This body also experiences a force, this body also experiences a force in these directions. In delta t means you can consider impulse. Force into time nothing but impulse. This body also experiences a impulse, this body also experiences a impulse, right? After that, if suppose the body is moving with v2 velocity, so here m1 is moving with v1 velocity, then before collision the total momentum is 25, right? After collision also the total momentum, the sum of the momentum, vector sum of the momentum should be equals to 25. In that case what happens, mass is not changing, means here definitely velocity will changes. For example, it is moving 10 meter per second, it is moving 5 meter per second, means 15 meter per second. Finally what may happen means its speed will decreases during collision, this body speed will decreases, it may come to 7 and this body speed may increases, it may come to 8. Again you see, before also 15 meter per second, now also 7 plus 8, that is 15 meter per second. Velocities may exchange, velocities will exchange, okay, but total momentum remains same. That is called law of conservation of momentum. For this a very small derivation is there, you have to practice. So see here, so you have to write considerations. I am writing directly the conditions here, that is impulse experienced by m1. Impulse experienced by m1 is f12, that is f12 into delta t. This is what only the impulse experienced by m1, right? f12 into delta t. This should be equals to change in momentum. Impulse is nothing but change in momentum. This is equals to change in momentum means what? Final momentum minus initial momentum. Final momentum of first body. Final momentum of first body is m1 v1 minus initial momentum of first body is m1 u1. This is change in momentum. And I will write here impulse experienced by m2, mass m2. So for that how can I write f21, this is the impulse experienced by mass m2, f21 into delta t. This equals, again I can able to write change in momentum. Impulse means change in momentum, that I can able to write m2 finally moving with v2 velocity, that is final momentum m2 v2 minus initial momentum m1 u2. Okay, initially it is moving with u2 velocity. So after writing this impulse, okay, impulse experienced by m1 mass, impulse experienced by m2 mass, then here delta t time interval is same for both. Okay, for m1 mass also, m2 mass also, it experiencing impulse, this delta time t is same only, right? Then you can cancel that one, and according to Newton's third law, this F12 force is equals to minus F21 force. Okay, this F12 force is equals to minus F21 force. And then here you can write F12 means the delta t, if you get cancel, you can write m1 v1 minus m1 u1 is equals to m2 v2 minus m2 v2 minus m2 u2. So here minus sign is there. Then if you see m1 v1 minus m1 u1 is equals to minus m2 v2 plus m2 u2. Then rearrange, you will get m1 u1 plus m2 u2. If you rearrange, see carefully and rearrange, you will get m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. So observe the last step carefully. m1 u1 plus m2 u2, that is initial momentum of a system before collision, is equal to m1 v1 plus m2 v2, that is the total momentum of a system after collision. So before collision the total momentum is equals to the total momentum after collision, that is total momentum is conserved. This is what? Law of conservation of momentum. This is valid when net external force is 0. If you consider net external force on a system, then it is not valid. So individual momentums may change, but the sum will remain the same. So practice this derivation for 3 or 5 marks. Law of conservation of momentum. And now we will see some examples of this law of moment of conservation. Some basic examples are rocket propulsion and recoil of gun, or if a man jump from a boat, then definitely to conserve the momentum the boat will move away from the shore. That is also example for law of conservation of momentum. So there are so many examples we can give for law of conservation of momentum. And here I will explain this concept that is called recoil of gun. Okay. So what do you mean by this recoil of gun? For that, let us consider a gun. Right. This is gun. So old model gun, let us consider. Then inside a gun there is a bullet, not a dummy gun or empty gun. Inside a gun there is a bullet, and this bullet mass, let us take it as small m. Then the gun mass, let us take it as capital M. So bullet is inside the gun only, right? Then this bullet and the gun is a system, right? If you throw a gun, along with the gun, the bullet also will move while throwing. So like that you can consider this is a system. Then what is the momentum of this system before firing? So before firing, its momentum, initial momentum is 0. It is at rest, right? Once you fire, then what happens? The bullet will move forward direction with some velocity. So the bullet velocity, let us take it as Vb. Similarly, how the bullet will move in forward direction, this gun also will move backward direction. Okay, bullet will move with very high speed, but gun will move with less speed. Why? Because its inertia is more, mass is more, isn't it? How much fast bullet will fast? In that fast gun will not move in backward direction. gun will move in backward direction, but its velocity is less. Why? Because gun mass is more. Right. Then before firing, the momentum is 0 means after firing also the system momentum should be 0. What is the total momentum of the system after firing? Mass of the bullet into velocity of the bullet plus mass of the gun into velocity of the gun. This is the total momentum after firing. This should be equal to 0. Why? Because after firing the total momentum is equals to total momentum before firing. Before firing is 0, right? Then from this expression, mvg is equals to minus mvb, or vg is equals to minus mvb by capital M. So here recoil speed, okay, recoil speed of gun. So here Vg is what? Vg is nothing but recoil speed of gun, okay, in which velocity the gun will move backward, right? That speed is called recoil speed. That expression is mvb divided by capital M. See here, if mass of gun is more, the speed of gun will become less. Because of this reason, you may observe while firing, the soldiers what they will do means they will hold the gun very tightly to the their shoulder, isn't it? Why? Because by keeping very tight to the shoulder, the mass, effective mass become more. Why? In that case, when the gun is attached to the shoulder, right? In that case, the total mass become mass of the gun plus mass of the person. Okay, then the mass will increases, the recoil speed will decreases. Remember this formula. And here for competitive exams, remember some points. Write as a note, that is kinetic energy. In this case, kinetic energy will not conserve, momentum only will conserve. Here kinetic energy is equals to normal formula of mv square. So multiply by m and m, then you will get kinetic energy is equals to half m square v square, m square v square by m. mv means momentum p, m square v square means p square by 2m. This is the kinetic energy expression. Remember, this is also one formula. P square by 2m is also one formula of kinetic energy. Then in this case, momentum is conserved. Momentum is conserved means P is constant, momentum is constant, right? Then kinetic energy is inversely proportional to mass. Remember this point. Kinetic energy is inversely proportional to mass. Then I can able to write kinetic energy of gun, ratio of kinetic energy of gun by ratio of kinetic energy of bullet. This is equals to mass of the bullet by mass of the gun. So remember this points for competitive exam. Kinetic energy is inversely proportional to mass in law of conservation of momentum. Some other examples for this law of conservation of momentum. So next example is, you can consider an explosion. In this explosion, let us consider a shell or a bomb explodes. When it explodes into two fragments, means two pieces, like that you consider, when it explodes into two fragments. So before explosion, what is its momentum? Its momentum before explosion is 0, right? Initial momentum. Now it has to explode. Final momentum of the system also should be equal to 0. So for that, this is m1 mass, it is making into two pieces, and this is m2 mass. In which way they have to move means, one fragment is moving in this direction, another fragment exactly it should move with opposite direction. Hence these two momentum get cancels each other and total momentum become 0. I hope you understood this one. Why? Because initial momentum 0 means finally the system momentum has to become 0, means one is moving in one direction, means another mass definitely has to move in opposite direction. Then this momentum vector's magnitude is same, moving opposite direction, they get cancelled, the final momentum of the system also become 0. Then here you can consider this is P1 momentum, this is P2 momentum. So this system total momentum P1 plus P2, this is final momentum of the system, right? P1 plus P2. This should be equals to initial momentum. Initial momentum, it is at rest before explosion, that is 0. Then P1 is equals to minus P2. This negative sign indicates they have to move in opposite direction. Then the momentum will conserve. So in case of two fragments, if it is exploding into three fragments, fragments will fly off, then how they have to move. So these are important for competitive exams. These points, small points you remember. Now you have studied two fragments, means they have to move exactly opposite to each other. Suppose three fragments means one fragment is moving in this direction, another fragment is moving in this direction. This mass is m1, this mass is this velocity is v1, this is m2, this is v2 velocity. Then these are two vectors, right? So like this you can join these two vectors. Vectors means you can take the vector and you can move in the space, it is allowed, but you should not change the direction. Okay, you should not change the direction, you should not change the magnitude. So what I am doing, I am taking this vector, I am placing here without changing direction. This vector also I am taking, I am placing here without changing direction, that is allowed. And this is one vector, okay, this is a P1 momentum vector, this is P2 momentum vector, means for these two vectors you will get a resultant, right, according to parallelogram law of vector addition. You have to see the videos of parallelogram law of vector addition in motion in a plane, then only you can understand. So from this point, this is the resultant of these two vectors. This is P1 vector, this is P2 vector, means this is the resultant of P1 and P2 vector, right? So then this vector is P1 plus P2 vector. Okay, then in another fragment has to move in which direction, means finally the total momentum become 0. In such a way it has to move. So another fragment will move in this direction. Why? Because this is the resultant of these two, right, P1 and P2. So then if the another mass m3, if it is moving with v3 in this direction, then this vector is exactly opposite to this vector, then they will get cancel each other, then the total momentum of the system also become 0. So in this way it has to move. And next, Suppose in the same concept, in the three fragments concept only, one fragment is moving in this direction. One fragment is moving in this direction and another fragment is moving right angle to it in this direction, that has exploded. This is M1 V1, this is M2 V2, both are moving right angle to each other. The third fragment, in which direction has to move? So see here, this is one vector, this is another vector, right? This is the resultant of two vector. So this is P1 momentum and this is P2 momentum. Then this is the resultant of P1 and P2, P1 momentum plus P2 momentum. So it has to become 0 means another fragment has to move in this direction, right? Isn't it? Then what is its magnitude? See here, finally these two are equal in magnitude, opposite in direction, hence they are getting cancelled and final momentum of a system is become 0. That means both are in same magnitude, means what is the magnitude of this vector? This is P1 and this is P2 vector, means this is P3 vector, right? M3 V3, this is P3 vector. That P3 vector magnitude is equals to, you apply the parallelogram law of vector addition or directly you apply, you find this value, you will get P1 square plus P2 square. Okay, this is the magnitude. And also in case that is one shell breaks into two fragments, one will move in this direction with M1 V1 velocity, another will move with some velocity, that is mass M2 U2, M2 mass V2 velocity. In that case, remember always this total momentum is conserved, means M into V is constant, P is constant means MV is also constant, then M is V is inversely proportional to M. V is inversely proportional to M means you can consider in this case, especially into two fragments, the ratio of velocity V1 by V2 is equals to M2 by M1. So remember these points, these examples useful for competitive exams. I hope you understood law of conservation of momentum. Thank you.